Okay, we're at test hint number 20 that says how to distinguish between empirical and molecular formulas in general. Like, what are the basic characteristics? This is one of those, which of the following is not? Well, you need to know that the empirical ones are reduced down, molecular ones can be multiples, they're going to have the same elements, they'll boil down to the same empirical formula if we reduced everything, and then really that's about all there is to it. And that takes us to the short answer problems.
Yes, this seems like a short test, but there can be a lot of work involved in each question. So don't look at this and say, hey, there's only 25 questions. We've done 40 question tests before. Don't think this is a snoozer.
Right. And when we get to the short answer questions on the test, you're going to be asked to do the same math that you had to do to answer the multiple choice questions. Now you have to show us your work and everything, so we know really that you know how to do that instead of just picking an answer that looks good.
So we want to see you set things up. We want to be able to read. We want to be able to find how you got from one step to another. If you just have a bunch of numbers down there and one of them happens to be circled,
yeah, no, that's not going to cut it.
That won't do.
Label things.
Yeah.
Unit and label. Okay, we want to see the train track method or the factor label method for all of these. Make sure you're clearly stating everything, otherwise you're going to be here forever during corrections, redoing and redoing and redoing.
Yes.
Okay, 21. How to calculate the number of molecules in a given mass of a compound. So, we're going to go all the way from grams
To
to
molecules.
molecules. And we need to step on something in the way. We need to step on the mole.
On the mole.
Step on the mole to get from grams to moles to molecules, or from molecules to moles to grams.
2 conversion steps. This is 2 conversion steps. And you can string them all together.
Sure.
Some of you are going to want to stop
Yeah.
and then start again, so you have 2 separate problems, or you can string them all together. Give us the number, give us the unit, and the appropriate label.
Yeah, and I think if you go back and look at the PowerPoint that we have of the expanded test hints, you can see some examples there.
Yeah.
Alrighty, 22.
22, how to calculate the percent by mass of an element in a given compound. Well, we've already done that twice on the multiple choice part of the test.
Right. Remember that the element is part of the whole thing.
Right.
So if it's something like C6H12O6, okay, part of that's carbon, part of it's hydrogen, part of it's oxygen. The whole sample has a mass. Just the carbon atoms have a particular mass. Element divided by the whole compound times the height.
Right. Number 23, how to calculate the molecular formula of a compound when given the empirical formulas and the molecular masses.
Yeah, I remember this one last year. They were having a hard time with this, and it's like simple.
Yeah, we sort of cut to the chase a little bit.
Yeah, we kind of gave them too much information, I guess. If we say that the empirical formula is HO, 1 hydrogen, 1 oxygen, but the molar mass, or the molecular mass, is, what, 34? Okay, well, then what's the molecular formula? So you have to ask yourself, well, I know the empirical formula, I know that empirical formula has 1 hydrogen and 1 oxygen in it. I wonder what the mass of 1 hydrogen and 1 oxygen is.
But the molar mass is 34. Well, the empirical formula mass, the mass of the empirical formula mass is only 17 grams.
Right. 1 from hydrogen, 16 from oxygen. We're rounding off here just to clarify.
And this, just by eyeballing it, that's twice as big.
Right. Well, if this molar mass is twice as big as what the mass of the empirical formula is, then the molecular formula must be twice as big.
Right.
So it's not 1 H and 1 O, it's actually
2 H's and 2 O's. It's just multiply everything by 2.
Okay.
24.
24. Nice problem.
Yeah, this is a good one.
This goes back to your percent water in hydrate, the hydrate lab, percent of water in a hydrated compound.
Magnesium
And
sulfate.
it's essentially giving you lab data where you have the masses of substances before and after heating, and you need to figure out how much water was lost. And you know the empirical formula, except you don't know how many waters are attached. And the key to this is understanding there's a ratio between the moles of water and the moles of the ionic compound, the anhydrate,
Anhydrous.
we call it.
And they use that vocab.
Yes.
So you need to study that
That
lab.
vocab. You need to study that lab very carefully. I think we have some practice problems on this posted
Yeah, we do.
on Moodle that you can take a look at, and certainly the expanded test hint PowerPoint is going to be helpful to you. But find moles and do a ratio of moles of water to moles of the compound. Don't just kind of decipher, weed your way through the information that's given and get down to moles.
If you did that water hydration lab, you should be fine on this.
And do the calculations yourself and really
Mhm.
try to understand it, you should be good. But this one, I think you'll probably spend a little time
Yes.
on this problem.
Yeah.
Last one.
25. How to calculate the empirical and molecular formulas when given mass percentages of each element and the molecular mass of the compound. You guys have done some sample problems like this. We actually just worked one out with carbon and hydrogen just a minute ago. And
Yeah, so it's like taking our sample problem that we just did for carbon and hydrogen and adding this other step. Like, well, what if you added up the masses for the empirical formula, but the molar mass was actually double or triple or
Right.
quadruple or 6 times or 20 times?
right.
Then you just multiply your subscripts by that factor. So it is a 2-part problem, and the math is all something that you can do. You just need to stop and think. And I don't know, do you recommend for your kids to try the short answer first, or do you have them work through some things in multiple choice?
I would rather see them work through some things on multiple choice, and then do their best on the short answer questions, because there are so many more
Of the multiple choice.
multiple choice, and there are some hints
Yeah,
within those multiple choice questions that if you're alert while they're taking the test, it's possible you go, oh wait, how did I do that one?
Yeah,
And look back,
sure.
which could help.
Right, and we even give them 2 bonus questions
Right. And
on this. So.
students who have prepared will go rather quickly through the multiple choice questions.
Right. Very good. Happy studying, everybody.
Good chemistry.